Hi everybody, Mrs. Bolin here, and we are still looking at Learning Target 5.3, and we're going to continue on the back side of our notes. We'll still do step 1 where we're adding the equations vertically so one variable gets canceled or eliminated, but there's one additional step that we're going to have to do, and so let's add a set of parentheses here, and I'm going to write may have to multiply one or both equations. May have to multiply one or both equations. So I'm continuing on from what we previously learned for solving systems of equations by elimination. But now we'll see we might not be able to use elimination right off the bat. We may have to multiply one or even both of our equations. So we can go ahead, flip to our backside, and example 3 says to solve the system by elimination. And so we know we're trying to create the addition problem, and so that either our x's or our y's drop out of the problem. But right here I'm noticing my x's aren't canceling and my y's aren't canceling. So I need to multiply one equation. I can make a note here. We're going to multiply one equation, and I'm going to have to do that so that one of my variables will drop out of the problem. So I want to look for things that are multiples of each other. For example, I can easily do -7 times 2, and I would get -14, and then 14 and -14 would cancel. Whereas if I look at my y's, it won't actually work with my y's in this problem because I can't do 2 times a number to get 9. So you're looking for a way to either cancel your x's or cancel your y's. And I mentioned that if I multiply this bottom equation by 2, then my x's will cancel. So what I'm going to do is I'll draw an arrow right here, and I'm going to multiply 2 times -7x, and I get -14x. I also have to do 2 times my other terms. So this is, think of it like distributive property. I have to distribute this 2 to every term in this equation. So I also need to do 2 times 2y to get 4y. And don't forget to multiply the 2 by your constant term. 2 times 6 gives us 12. So I multiplied all 3 terms of the equation by 2. And so here's my newly written equation. And then my top equation can stay exactly the same. So I'm just going to rewrite that so that I have it aligned. 14x minus 9y equals 8. And now I've got one big addition problem. So again, now I can add vertically. So 14x plus a -14x, or 14x minus 14x, good, it cancels. That was our whole idea here with elimination, is we wanted one of our variables to get eliminated. -9 plus 4y gives me -5y. 8 plus 12 gives me 20. So now I'm trying to solve for y. -5 times y can be undone by dividing by -5 on both sides. And I get that y equals -4. So here's half of my solution. I'm going to come over here and I need to plug this -4 back into one of my original equations. It doesn't matter which equation you choose. I'll choose this first equation here. So I'm going to write 14x minus 9, but instead of writing the y, I'll put parentheses because I'll plug in what I found y to be. So again, I've got 14x minus 9 times parentheses equals 8. And I'm plugging in that I found y to be -4. I can simplify here. I'll have 14x, -9 times -4 gives me a positive 36. I can subtract 36 from both sides, and I get 14x equals 8 minus 36 gives me -28. My last step here is to divide by 14 to get x by itself, and I get that x equals -2. So now I know my x and my y value. I can write my final solution as an ordered pair. So I have -2 comma, -4 as a final answer. Let's take a look at example 4. So in example 4, hopefully you're noticing there's nothing that gets eliminated right away, right? My x's don't drop out, my y's don't drop out. And so I want to look for one of these equations that I could multiply by a number so that either my x's or my y's drop out of the problem. I see right here that if I do 4 times 2, I get 8. So that's a good sign. But if I want my y's to drop out of the problem, and this is a positive 8y, I would need to make this equation have a negative 8y, so that negative 8y and positive 8y cancel or get eliminated. So what would I need to multiply this 4y by so that I can get a negative 8y? I would have to multiply it by a -2. So out front, I'm putting a -2. Again, think of it like distributive property. I need to do -2 times each of these terms. And I'm putting an arrow here so I can rewrite my equation. So -2 times -6x gives me 12x. -2 times 4y gives me -8y. And -2 times -14 gives me positive 28. My second equation, I'm going to leave it exactly as it is, so I'll just rewrite it. 4x plus 8y equals -12. And then I'm doing my big addition problem. 12x plus 4x gives me 16x. My y's cancel out. -8y plus 8y, good, it drops out. And 28 plus a -12, or I could say 28 minus 12 gives me 16. So my y's canceled out. I'm trying to get x by itself here. I can divide by 16 on both sides to get x by itself, and I'll get that x equals 1. So now I need to plug x equals 1 back into one of my original equations. Doesn't matter which equation I choose, I'll just choose this first equation. So I have -6. Instead of writing the x, I'll put parentheses because I'm going to plug in what we found x to be. So -6 parentheses plus 4y equals -14. I know x is 1, so I can plug in 1. -6 times 1 gives me -6 plus 4y equals -14. Trying to get y by itself, I only have one variable here. I need to add 6 to both sides, and I'll get 4y equals -14 plus 6 gives me a -8. My last step here, divide by 4, and I get y equals -2. So now I have both parts to my solution, x comma y, or 1 comma -2. And let's do one more example together. Example 5. So if we take a look at example 5, I can see that my x's aren't canceling and my y's aren't canceling. So I'm going to have to multiply one of my equations here. I can't do 6 times a number to get 7, but I can do 3 times a number to get 12, right? If I do 3 times 4, I'll get 12. And here a 12 and a -12 will cancel. So I want to multiply my top equation by 4. And again, I'm doing that because when I do 4 times 3y, I'll get 12y, which will cancel with -12y. So I need to distribute this 4 to every term. So 4 times 7x gives me 28x. 4 times 3y gives me positive 12y. And 4 times 18 gives me 72. My bottom equation is staying exactly as I have it. 6x minus 12y equals 30. And now I've got an addition problem. Add my x's. 28x plus 6x gives me 34x. 12y minus 12y cancels out, so I've got no more y's in the problem. 72 plus 30 gives me 102. So here I'm left trying to get x by itself. I can divide by 34 on both sides. and I get that x equals 3. So now that I know x equals 3, I need to plug this x in for x in one of my original equations. It doesn't matter which equation I choose, I'll just choose the first one. So I'll write 7 parentheses because I'm going to plug in 3 for x. So 7 parentheses plus 3y equals 18. And I'm plugging in 3 for x. So 7 times 3 is 21 plus 3y equals 18. Now I need to subtract 21 from both sides, and I get 3y equals -3. My last step is to divide by 3 to get y by itself, and I get that y is -1. And I can write my solution as an ordered pair, x comma y, or 3 comma -1. All right, so you have one you try. Keep in mind you'll have to multiply one of your equations here. So take a moment and see what you come up with. Go ahead and pause the video. Let's see how you did. On this you try, I ended up multiplying my bottom equation by -2, because if I do -2 times -2x, I'll get a positive 4x. And here we can see that positive 4x and -4x cancel, so my x's drop out of the problem. By doing that, I got that y equals -1. I plugged y equals -1 in for y in my top equation, and I ended up getting x equals 3. So my solution was 3 comma -1.